Looks like we're live, I think. I'm pretty sure. Wait for confirmation. Slow, but looks like that's me. All right, so we're done with that, and we're done with this, I think. Probably. And I don't think we'll draw yet. So we're going to deal with a couple of subjects. The interferometer and the two-slit experiment, the most famous bits of interference stuff. And as I've kind of clearly argued, I don't think there's any such thing as wave interference for anything that's not really waving. Okay, so it has to be a medium that has a wave in it for there to be wave interference. So yes, water waves and I don't know, waves of some other kind of liquid, waves in sound in the atmosphere. But photons and electrons and atoms and all this stuff, they're particles like sand. They're not in a medium. They're not tied to each other. There's no tension. They don't exist in. There's no way they can be anything wave-like, and certainly they can't do something called interfere with it themselves. So, I mean, it is kind of laughable that you have to actually argue that things can't interfere with themselves. I mean, it's just kind of a really? I have to do that? I have to actually defend the premise that things can't interfere with themselves? But you do have to. All right, so I'm going to play some of this Bill Gates video, Rational Science. And frankly, I like 85% of what this guy says. As long as he's not talking about his theory, he's pretty rational. But as soon as he gets on this whole rope thing, rope is somehow a good replacement for the quantum crap, which is just, in my opinion, I don't even know how you even start there. It's just so, you might as well be making the universe out of dead cat hair. The rope's made out of dead cat hair. I mean, it's just, there's no point. So anyway, at the end of this video, he does a summation of the two-slit sort of history, and it's got some glaring, in my opinion, flaws in his summation. So I figure that would be worth going over and such. So I'll do that. Housekeeping here. So many things to keep track of. What the hell is that? So much to do, so few to do it. Okay, don't fall over. Okay, didn't fall over. All right, so let's play the video, as they say, to the videotape. Might have to increase the volume. Better do that first, I suppose. Yeah, you have to hear the volume through my computer, so I do need it loud. All right, so he was talking about Schrodinger's cat, and he didn't quite get that one right either, because Schrodinger was really sort of mocking the idea of entanglement superposition. He wasn't seriously making an argument for it.
Where did they get even that? And here it is.
I do have it sped up a little bit. Maybe I'll speed it up a little less. 125 instead of 1.5, just to be a little fairer.
Here's where they get all this nonsense, and it comes from the slit experiment. Okay, what is the slit experiment?
All over the place.
Yeah. That's how they came out. They could never explain the slit experiment. That's the bottom line. They could not explain with particles. So
again, he's saying they can't explain it with particles. They don't explain it as particles. That's the irony of his complaint. They're clearly not particles when they're waving through this. He's drawing the wave mechanics. He's basically demonstrating how they don't consider it really particles. They just have particles when it lands. But the whole mechanism is based on a wave theory. So again, it's just, it's just such a straw man argument to say, here, I'm arguing with particle theory by using an example where they always call light a wave. They never call it a particle. So again, it's just such a cheat of the argument.
Explain it with waves, but they say, you know, what do we do with wave? We're not wave theorists, we're particle theorists.
Well, like, obviously they're wave theorists. It's just, I don't know how you can get away with saying that. They've clearly said this thing called a photon is some kind of field thing, that it's a sine wave in two different mediums, you know, some sort of electro field and some sort of magno field. So again, it's just such a false argument to say having something perturbate or wave through a medium has something to do with a particle theory. Please.
Quantum is not about waves. Quantum is about...
Yes, that's all it's about. Obviously, this whole interference idea is dependent on the idea of waves. There's no interference without the waves. You have to make waves for the waves to interfere with each other. So clearly it's dependent on that. And the people who have made some separation from that, like Feynman, you know, where they don't emphasize this wave math and they try to emphasize the fact that it's just a probability wave, not a real wave.
You know, particles, and the wave we use only when we need a crutch. When, you know, when we can't explain something, then we use the wave. So what happens? Turns out that they say, look.
Okay, so we know that some of this illustration is nonsense. It doesn't happen that way. There's no single slit that creates a big pile and that's it. We know the single slit creates the same kind of pattern. So it's just more lies about what was previously understood, known by Newton.
You throw if you try to explain it with particles, right? When you do the slit experiment, you try to explain it with particles. What do you have to assume? You have to assume that the particle is at two places at once.
So more nonsense. You don't have to assume anything. You can just say a particle goes through one slit or the other slit. And the fact is that as I make the slit smaller, I increase the likelihood that the particle will interact with the material differences, the transition from one material to another. And we know that that transition always has a refractive index. We know that matter doesn't transition where one kind of matter just transitions into another kind of matter, and there's no weird layer in between the two. There's always a weird layer where there's atoms from one getting into the atoms of the other. Right, this surface right here has some atmosphere. Oxygen and nitrogen and other chemicals are going into this material, and this plastic is actually leaking hydrocarbons and different other kinds of compounds, atoms, that are drifting into the atmosphere. It's just a truth. It's a complex surface, not a line.
The particle is not at one slit or the other. The particle is at both slits simultaneously.
Right. So there's no obligation to go for any of that nonsense. No obligation to believe in Santa Claus. So I don't have to believe in elves, and I don't have to believe in reindeer. Okay. If I don't jump for the Santa Claus lie, I don't have to do any of this crap. Okay. I can come up with a rational explanation for who put the presents under the tree.
Okay. And that's when you have to take a beer and to try to see if you can visualize this thing. The particles at both places at once. In this case, they did it with electrons. And the way they prove it to themselves, they said, look, all these particles bunch up and form these waves that you see there, you know, and so they have a wave behavior.
So again, they don't really form anything called a wave in any kind of real way. There's no wave anywhere there's no wave. This is all just illustrations. There's no image of a wave in the real experiment. There's no evidence of a wave in the real experiment. There's nothing that says I have to be a wave. That's just their assumption.
Here, because the particle is everywhere at once, it's both a concentrated little dot as well as an extended thing that like a feet.
So he's showing the single slit, and he just showed them all clumping up in one spot over here. So I just want to point out how we know that's not what a single slit's going to do. So that argument is just bogus. So this illustration is not accurate.
Field that covers the entire universe, so it's both, and with that they cover all the bases. And they say, look, the way we prove this is we're going to block one of the slits, and here they're going to block the bottom one, and they say, look, when we block the bottom one, then we don't have interference patterns on the screen. See,
but we know that that's not true. So we know that when you block one of the slits, there's still a single slit left over, and the single slit will produce a pattern. So we already know that that's just a canard. That's not have anything to do with reality. Okay, you can't use that as a look at the big difference between. There won't be a big difference between. The single slit will create a pattern, the double slit will create a pattern, and the patterns will be subtly different, not dramatically different. So again, this is just more kind of lie about some sort of expectation about, well, if you were throwing tennis balls through a window, you would expect them all to go right in a pile. But we're not throwing tennis balls through a window. We're throwing tiny atomic particles through a complex mixed structure. Has no correlates to throwing through windows.
The dot, the electron in this case, just goes through one slit.
So it just says in the text there that the pattern disappears when you block one of the slits. That experiment, if ever done, will not come up with those results. So that's just a lie. This in the double slit experiment, the slit width in both these slits is still small enough to create a single slit pattern. So there will not just be a clump of balls on one side when you block one of the slits. So it's just a lie. It's wrong. It's completely inaccurate. It's provably inaccurate.
To go through the other one, and that's the explanation they give it. And they say, see, we've proven it. We've proven that light consists of particles.
So again, he says they used the two-slit experiment to prove light consists of particles, when we know it's exactly the opposite. They used the two-slit experiment to prove light is a wave. So, this argument is just so dishonest. It's just totally wrong. It's exactly 180 degrees to the truth. It's completely inaccurate. Completely. You can't be more inaccurate in describing the reality. Nobody uses the two-slit experiment to prove light's particles. They use the two-slit to prove light's a wave. To demonstrate, to provide evidence of, to convince suckers.
And we know this, that the particle is at two places at once, and we know this because when you block one of the slits.
Well, obviously they don't argue that the particle's in two places at once, so he's not getting that. He's not honest to their quantum mechanical argument here, which is the wave function, okay, is created. Two waves are created. Now, yes, Huygens says there should be four waves. Yeah, but whatever. Their inconsistent principle that they apply inconsistently creates these two wave functions that go through both slits, but there's no superposition argument. No one's arguing the actual photon is in both places at once.
Then you don't get the interference pattern. That's their logic. That's their rationale.
Well, again, it might be some of them do actually make that argument, which is specious, and should just point out how that doesn't happen. I block one of the slits. The other slit is still a single slit. The single slit will create a pattern. That's the honest answer. Obviously, this is very deceptive because they always, you have to draw it in these limited conditions. So you have to remember this size is tiny. This whole experiment is 3 millimeters across, and this target's going to be meters across, and it's going to be meters away. So there's a little bit of deception about all this angular difference. There's not going to be this huge angular difference between the photons and their arrival location.
Okay, so from this, then they say, then they go to Schrodinger and Schrodinger's cat, and they say, the particles at both places at once. The cat is in both states at the same time.
All right, so I think those two arguments even in conventional physics, those two arguments are separate arguments. The double slit experiment is used to demonstrate a wave function that photons, they claim, have. And Schrodinger's cat is about superposition, which is a different argument. And it's more about collapsing the wave function. It's about having a target. It's not about waves. It's about collapsing waves.
know where the particle is until you look.
Right, and that's why they say Mother Nature's constantly fooling us, because every time we try to check the particle, we interfere with the experiment. In other words, every time you try to take a measurement, you're interfering with what you're trying to visualize.
And that is true, but it doesn't have the implication that they imply, which is somehow the universe is trying to stop us from seeing where something is. It's not trying to stop us. There's no Heisenberg syndrome where you narrow your information, you get more information, and somehow the universe takes information away. So if you get information about what the left hand is doing, you lose information about the right hand. There's no rule. There's just the fact that you make the environment dirty when you try to see. So when I create a fog so I can see the beam of a headlight, I make it harder to see anything with the headlight.
And so you can't do the two things at the same time. You can't see what is happening to try to get an idea of what is happening. And so you say, every time I touch the particle to see it, I move it. And because I move it, I've disturbed the experiment. So I can visualize, I can see it as long as I don't touch it. But once I try to touch it and visualize it,
right. And now we know they're using atoms, big clumps of atoms doing this experiment. And obviously those we could touch without destroying the pattern. They just have chosen not to do that experiment because I don't think it would demonstrate the truth they want to sell. They want to sell a description of reality that, in my opinion, is clearly not accurate, and they're going to do it by selectively choosing what facts they make apparent.
Interfering with Mother Nature. That's their logic for this whole thing.
They're using what do you call it? Inference. They're inferring
the
field part, and then when they look, they only see one location.
Yes,
that's the interesting thing, and they're also not seeing any photons. That's the other weird part.
And this is the trick.
The observation part where they're not actually seeing any particles.
This is the trick, guy.
But again, like I stated, when you use these bigger particles, you can actually see them. So you can actually videotape their voyage. You could put them in a cloud chamber and actually watch them plow through one slit and move at an angle. So they could actually do the experiment where you could actually see the experiment take place. You could see the causes and effects. But they don't do that. Because again, what they're going to see is not going to be what they're drawing. What you're going to see if they do the experiment won't be their drawing.
Yeah, what they do, they call it observe. They use this key word, observe, observation.
I like that word.
What they're observing is visible stuff. And they call the observation, we observed, we've proven it because we observed it. They're not referring to the invisible world. If they observed a gluon, they would be able to draw a gluon for you. If they observed an atom, they would be able to draw an atom for you. They can't.
Well, that's almost a bullshit argument, just because obviously what they are observing is a lot closer to a real observation than gluons and neutrinos and all that crap. So obviously this is a little closer to an actual observation.
They can't draw an atom because whatever they draw, they can't explain why the electron doesn't fly away. And so they just say it is so. They haven't seen, the electron flying around the atom because they say every time we try to see it, it changes location because we.
Well, again, that's sort of not true just because you have to push electrons. So with a voltage, so you can kind of know where they are just because you're actually pushing them. So you can kind of get a pretty good idea where they're going.
We pushed it with our eyes. We pushed it by throwing a photon at it.
Observation is the active acquisition of information from a primary source. Just acquisition of information in the vaguest term.
It's called inference. The correct word is inference, but they don't use inference because people say, then it's your P. You're inferring.
Deduction.
You're deducing, indirectly. They don't like that. They say, no, we've proven. And just
the two are not really the same subject. How much evidence? It's evidence. We have evidence of an event. We have evidence that the event looks something like water when you use two slits in water, similar kind of effect. Now, when you use a single slit in water, not similar. Maybe when you use 3 or 4 slits in water, not similar. but with two slits similar. So they have some evidence of a correlation. Now the point is do they have enough evidence to say we've proven that photons are in a wave tank? Photons are waves. Photons are moving through a medium. Photons are perturbations in a medium. Do we have evidence to draw that conclusion decisively and say that's the truth? Is it sufficient evidence to convict photons of being a wave? I would argue far short of that. Way short of that. Because there's lots of alternative explanations that don't require the existence of any waves.
Same with proven, they use the word observation, which is a very tricky
word. Detection is maybe closer, and really inference or deduction is really what they're doing. Because what do they actually see?
Here we have, hold it, we have a couple questions there. Dave Robinson, knowledge, justified truth.
Okay, so it's all perfectly reasonable to gather evidence and then make deductions, you know, put the evidence together and see where it points. The problem is the emphasis they put on the evidence, what facts are important facts and what facts are unimportant. So it's unimportant that the single slit doesn't have a correlation in water waves. It's important that the double slit does, that kind of thing. That's an obvious bias that's distorted perspective, which ruins the process of evaluating the evidence. They're selecting the evidence they choose to allow in the deduction pool.
Yeah, that's Mr. Plato there, right? And Steve.
So the truth is the quantum mechanics is really just particle hypothesis renamed. Yeah.
Yeah, and Steve is right about that as well. But let's continue here because I want to touch on a little subject here.
Yeah,
let's look at it.
What are they actually seeing?
Okay, and that's what we're going to do with the rope. Now, what are they really doing in there?
What are they actually seeing?
No, they're not seeing anything. That's
what are they going off of?
I showed you the squiggly lines the other day when there's they smash two particles or so they think they do.
All this from that?
Yeah, I know from that. They say, oh, this one has so much.
All right, so he's just really going on a more general subject, so we'll say that's enough. He's done with the two slit. But like I said, the rest of what he's saying isn't horrible stuff. You know, just pointing out that all this talk about what they know to be true, and they just know it by little shreds of evidence. There's no compelling evidence to somebody who's fair-minded. It's very weak evidence, very little evidence. So they draw you a picture of what's happening, but there isn't strong evidence that that's what's happening. Yeah, well, this is useless tripe. You have no idea what you're talking about. LOL. LOL, you can't apparently make a single fucking argument that touches on the evidence. So why don't you explain why isn't the photon experiment match the math? The math says it should be a wave. Okay, what hits the target should be gradually light, gradually dark, gradually light, gradually dark. And there's obviously bars of light in the two-slit pattern. So why don't you explain what that is? Why is that? Why does the photon experiment look entirely different than the electron experiment when the math says those two experiments should look the same? What you see should look the same. Why don't they look the same? I do know the math, asshole. The math is the Schrodinger wave equation, which is an angle equation. So why don't you explain why the math explicitly says it should be a sine wave? Why isn't the intensity of the light a sine wave? Will you explain that? How can I explain it if you don't know math? Well, again, how do you explain it with math? It's not the point is the math says that's what it's supposed to do, asshole. You're the one that obviously doesn't know the math. The math says, it predicts. The math explicitly predicts a sine wave. That's the probability. High probability at the tip, lower, 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 gradually lower. There's no math that says square little blob of light. The math doesn't say that shit for brain. It says gradual change from light to dark. Why isn't the fucking product match that prediction, asshole? Let's see your answer. Come on. Why do the two patterns look different? Why does electron pattern look completely different than photon pattern? Why? All you like to do is say random, okay, you're done. Okay, you don't have an answer. Okay, got it. Fuck off. Simple question. They just keep lying. You know, they just keep defending their bad theory with lies. Like somehow it has to do with me not understanding the math, because somehow the math is different for the two circumstances. That somehow the math for the electron experiment is different than the math for the photon experiment. No, same math, asshole. Ugh, pathetic. All right, so on to drawing about the interferometer. Okay, and so I just want to go over a couple of the basics. I mean, I keep asking this question, and I'll answer the question just because nobody else is. You know, the interferometer has this fundamental question you can ask, is where's the interference actually happening in the experiment? Okay, there's just no description. Whoa, not a very good lens, but you'll have to do. There's no description. It's not a very good either, but it'll have to do. All right, so we have the light coming in this way. Put an arrow here for source. And then it's received this way. Okay, as some sort of, you know, projection of a ringed pattern. Okay, now as I've pointed out, I can use a plain piece of glass, and just by having moisture on the surface, I can create that ringed pattern going through the piece of glass. So, you know, there's obviously something else going on here, but anyway, I'll get to that. All right, so the question is, yes, I hate this color selector. Anyway, all right, so you send photons in. The idea is that some of the photons go straight, 50%, 50% are bent. Now, the trick is what you're using to bend the light. Now, in Michelson-Morley, it was a half-silvered mirror, which means there's a bunch of single-slit experiments. And so the light ends up being diffracted, as I've argued. So the light taking this path, that is the one that goes through, spreads. And there's multiple mirrors on these paths. So you have to understand that the actual path is a bunch of reflections. And then it goes back the same way and comes back through the experiment. But for the purpose of just these illustrations, we'll just do this way. So you can sort of understand if the light's spreading as it comes out, then it's going to spread on its way back. All right, so this beam is spreading, and then when it gets back to the reflector, it's still spreading. So it's massively spreading. Okay, this beam massively spreads. And the other beam, which will make some other arbitrary color, purple. Okay, why not? So the other beam is just reflecting off the mirror. I have the mirror tilted the wrong way, obviously. So just pretend the mirror is tilted the right way. The one that reflects off the mirror, it doesn't spread. And it reflects off this other side. So it goes through. All right, it comes back. And it's not diverging. It's not getting wider and wider. And now it goes through the little slits. And so now it starts to diverge. So it has a tiny amount of divergence. So the one that gets reflected off the mirror diverges this little amount. And the one that went straight through and diverged right from the beginning, that one is diverged a lot. So the two beams, obviously, when they come back to this mirror, they're not two equal beams. One is spreading through the whole experiment, and the other is a beam through the whole experiment. Big difference. All right, now, this is probably worth redoing. So the question is, in quantum mechanics, they really don't say anything explicitly, except what we've learned from the two-slit experiment is when they send single photons, the experimental results are the same. That is, you get the same pattern with single photons at a time. So the implication of that is that the single photon is somehow, got to switch the color. The single photon somehow is creating two waves, and the two waves are interfering. There's not two photons that go through, and the two photons interfere with each other. So this interference thing, in that sense, the conclusion is that this interference is something the single photon can do because it creates wave functions. And there's no statement that the wave functions from one photon interfere with the wave functions of another photon. All right. So in the Michelson-Morley type interferometer, I'll put the mirror the right way this time. Probably the wrong way again, yes. Yeah, undo that, Gary. Undo is over here. Yeah, I want to go this way. Oh, color changed. Now that's interesting. How the hell did it do that? The color says black, and it's doing purple. That's pretty cool. I will not speculate. How's it doing that? Yeah, it's just not right. No, I'll change it because it's not right. Let's see if I just say select if it's going to be right. All right, let me use my arrow tool. That's probably going to make a nicer drawing. All right, so the light's coming in, and that could be fatter. And so the question is now what's going to happen if I send a single photon into the experiment? So there's just a single photon comes in here. Now, kind of obviously, the single photon can't both reflect off the mirror and go through one of the gaps in the mirror. So it kind of can't go both ways, right? So a single photon has to go one way, go this way. No, it's not going to be a very good mirror. Well, I can just make the mirror with two arrows, right? No. Not if you go that way, you can't, idiot. All right, so that's going to be the mirror, and this will be the other mirror, and such. Screw back over that like that. So that's a mirror. All right, so obviously the photon can't split in two here, because the only way it's going to split in two is if it goes through. If it hits the mirror, it doesn't split in two. Mirrors don't create wave interference. So if it hits the mirror, the photon goes straight across, hits another mirror, goes straight across, and then goes through, and then splits into two wave functions and creates a interference pattern. But it never goes this other length at all. So obviously there'll be no way for that. A single photon taking that path couldn't measure the difference between these two path lengths. So it wouldn't have anything to do with measuring a change in distance. And if the photon does go through, well, then it creates two waves that go to this mirror, and the two wave functions collapse on the mirror. And so now you have a bar pattern on the mirror, but it's not a bar pattern. It just means there's one spot that the photon goes to. So it either goes to this spot or it goes to this spot. And that means it has to come back, diverging. Again, we have this diverging problem. So the photon, if it was one of these fringes on the outside, that means that it has to hit the mirror on here, and then it'll bounce back, and it won't even hit the mirror. It'll diverge and miss the mirror altogether. That's one of the possibilities. So it could possibly go straight through and straight back. And then if it went straight back, though, it would go straight back through the mirror because it would have been hitting the same spot on the mirror So it can't really do that. So let's say it hits one of the, so it's diverging just a little. It's a little bit off center. So it comes back and it actually hits the mirror and goes this way. Well, what hit the mirror? The wave functions? Well, the wave functions collapse, so it won't be the wave function anymore. So what's coming back is just going to be the image of the photon, you know, a single photon reflecting off the mirror. And so the wave function collapses at the mirror. A single photon comes back. It hits the silver instead of going through one of the holes. There's a 50-50 chance it goes back through the holes and you never see it. But there's a 50-50 chance it hits one of the pieces of mirror, goes this way, and there'll be absolutely no wave function because it already collapsed the wave function on the mirror. So you're out of luck there. So clearly the experiment can't theoretically work with single photons. So clearly it needs there to be more than one photon going into the experiment. The photons have to take the different path. One, you know, then the two photons have to come back. You know, again, this one is diverging and it has a wave function. But it collapsed at the mirror. So we have the same problem. This photon, its wave function already collapsed. So when it comes back as a photon. This one comes back as a photon. This one goes through the mirror, so that means this wave, this photon will create a wave function. That is, it will create two waves that can interfere with each other. So it has some potential to create an interference pattern. But this other one's just going to hit the mirror. It's just going to be a straight photon. It's not going to have any wave function because it already collapsed on the mirror. It collapsed here. So how can this photon, the one that goes through, how can this photon have a wave function here that can interfere? It doesn't go through the opening slit. It doesn't Heisenberg. It already destroyed its Heisenberg wave function when it hit the mirror. It already collapsed its wave function. And it doesn't make a new wave function because it reflects off the mirror. And reflecting off the mirror does not make a wave function. So this photon has no wave function. Well, we don't need that. Undo that. Go back to drawing. So this photon is the one that returned this trip. This one doesn't have a wave function. So it can't possibly have its wave function communicate with these wave functions. So how does this create any kind of comparison between these two lengths? Again, how are they combined into the product, which is a photon pattern, you know, a place where photons land, a probability of landing, all right, that ends up describing a ringed pattern. You know, how do the single photons that land in these places, how do they land in these places? Okay, it's supposed to look like circles. You know, without drawing a circle, and then you won't have to actually draw the circles, but you get the idea that they're little dots that add up to circles eventually. But how does this non-wave function photon make these wave function photons create a pattern? So I'm just saying there's no theoretical foundation for this experiment. It can't theoretically work with single photons, and it can't theoretically work with multiple photons. It has no theoretical rationality. Now, does somebody explain to me how there is theoretical rationality here? In all honesty, I can't find the theoretical grounding. No, a photon is not a wave. I don't know why somebody would ask me that question. A wave of what? You know, I would say. A wave in what? What? How is it a wave? It never lands like a wave. It doesn't spread like a wave. So you have something that flies in the air just like a bullet. Like in every respect, it's kind of, most of the evidence indicates that, like a bullet, it travels through space and lands somewhere as a clump of bullet. Doesn't land as half a bullet, doesn't land as a quarter of a bullet. It's always a full bullet. Where waves spread and they get weaker and weaker as they go further away, the bullet always is a solid bullet, and the bullet doesn't go any slower, doesn't lose any momentum, doesn't lose any power. So if I hit something 500 yards away or I hit something 10 feet away, the same bullet hits, same amount of energy. That's what the evidence indicates. So when a photon travels 10 billion light years across space, okay, preposterous amount of distance, it's not a weaker bullet. It's the same bullet that left the sun that the light's coming off of. Same bullet. If the bullet would have hit me if I was 10 feet from the galaxy, the bullet would put a certain size and hole in my head. And from 10 billion light years away, it makes the same size hole in my head. Same bullet. There's no wave. Yeah, well, I guess you just don't understand here. This whole point of this channel is basically to argue how conventional science has false axioms. They have a bunch of religious notions of reality, and they're just completely wrong, and the evidence for them is insanely weak. So they have all these things they tell you are true. There is a Holy Ghost. They know he's there. Okay. Why? Because, there's a story where Jesus said he smelled the farts of the Holy Ghost. I don't know. No fucking evidence. I don't know. What is okay hypocrite? What does that mean? What does that mean? I mean, what have I said that's hypocrisy? Where's the hypocrisy in the drawing I just did? Where's the hypocrisy in a single thing I just said? Where? Where? Well, anyway, it's just another asshole who shows up, hasn't paid any attention, just talks shit out of their ass. Another unaccountable shit talker. There's way too many of them on planet Earth. Just anonymous cowards who have no reputation to defend, don't give a shit about reputation, don't give a shit about integrity or honor or any of that shit. They're just fucking assholes. So anyway, I've made the 2 points I wanted to make in this video, so I don't think I need to say any more. I'm just saying that clearly there's no theoretical grounding, as I keep saying, for interferometers doing this interference thing. Now, what there is grounding for, so let's redraw it, as a counter explanation for why interferometers work, okay, as tools to detect or measure distances, why they're very good rulers, is because of this very fact of the light divergence. So if you do create photons that are diverging, the advantage is that the divergence allows you to measure distance. Okay, so you can measure the travel distance by measuring this distance. So it gives you another way to measure distance, is to measure how much the light spreads, because it spreads proportionally through its path. So that's why the interferometer is a good ruler. Now, it's not the kind of ruler they think it is, where it's measuring the wavelength of a photon. It's not the precise instrument they think it is. It's a very sensitive instrument in the sense that it will, the pattern will change because of internal reflection in a glass. So as I've pointed out before, what the interferometer is really doing is the beam splitter is not splitting the light, in the sense that if I have dirt on this surface, you can sort of understand that that looks like a slit experiment. And when the light goes through the openings, it diverges, which means it starts taking these weird angles. And these weird angles mean the light refracts inside the glass. It becomes an internal reflection. And by the laws of probability and the reflective index of the glass, or whatever the substance is, crystal, there's a certain probability of the light leaving here, or the light leaving here, or the light leaving here. And you can sort of understand that if I spread that out, these different leaving points essentially create rings. This would be the inner ring. This would be the next ring. This would be the next ring. So that's creating the ringed pattern. Is the light that does go through the openings creates internal reflections inside the glass. The higher this angle, understand, the steeper this angle, the more likely the light stays in the glass. So the straighter the light goes through, the more likely it just keeps going straight through. So there's only an 4 to 8% chance of reflection if the light goes straight. But the more I change this angle, that 4% changes to 12, 15, 20, 30, 40, 50%, 90%. So the higher I make this angle, the steeper, the more likely the photon will continue to reflect inside the glass. And it still has a probability of 9 out of 10 times it hits a surface. So it could be at a certain angle, there's a 9 out of 10 times it will internally reflect, but there's still a 1% chance it leaves the glass. So you can sort of understand that it could go 4 times, it could go 7 times, it could go 9 times. I'm just saying, you know, the law of averages is it'll be 1 out of 9 over time. But in any one circumstance, you can flip the heads the first roll. Like you could roll dice and get snake eyes on the first roll. Doesn't mean that snake eyes was more likely, just means that that's how it turned out. But probabilistically, the more photons you put into the experiment, the more it'll come out to be exactly these ratios, where it's more likely to be in this ring and less likely to be in this ring and less likely to be in this ring, and that kind of argument by these rigid percentages. All right. So just for clarification, that's what I argue interferometers are really doing. They're diverging light, creating internal reflections, and the internal reflections are creating the pattern. And the pattern is completely consistent with that notion, just because unlike the slit experiments, these rings have a bit of a difference in their distances and thicknesses. And again, they would completely correspond to the likelihood of emission based on refractive indexes. So that's the counter theory. How do you know a photon exists? Well, there's a whole bunch of experiments. So I'm just going to block you now, right? Because you're just a waste of time. The subject really isn't how do we know photons exist. They think they exist. I think they exist. That's not part of the disagreement, retard. The disagreement is, what's the fucking photon doing? Is it waving? Is it in a medium? Is it made by water? Is it a wave in water? Or is it a discrete thing, a corpuscle, as Feynman would say? That's the argument, shithead. You lost a viewer. Bye. Well, I was going to block you anyway, retard. So fine. Bye. You're an idiot. So another stupid statement, I guess. A photon exists as much as eigenstates exist. What does that even mean? You know, what are these different sock accounts? Or I should just block you? Is that it? Berry? Your different forms of berry, raspberry, whiskberry, fuck off berry, fuck you in the ass till dead berry. Yeah. What's the fuck? Jesus. I just don't know why you people show up here. I mean, what's the... You don't have anything better to do with your time. Amazing. I mean, really amazing. And they do it on a channel, like I said, where I'm pointing out how humans are worthless sacks of shit, and they just keep making my argument for me. I mean, no doubt these are, probably a bunch of people who talk about how other people's IQs are too low. And this is what they're doing on the internet. Quite hilarious. So, brutally hot in here. Insufferably hot. But it's better than too cold, so I'll take it. There, it's a bit messy. That'll have to do. So let's see. I've did the two slit, made the interferometer argument, pointed out the alternative explanation for the pattern. Let's see, anything else needs to be done. So I'm just saying, all this stuff about interference, there's no hard evidence that in any part of nuclear physics, any wave ever interferes with some other wave to create a consequence. What there's evidence of is the fact that when electrons are hit by a photon, the photon will often change its directional vector. It will move in a new direction. That's a pretty well established fact. And it doesn't require any waves. It just means the electron has a motion in space. And when the photon hits it, it can hit it when the electron's moving towards it. It can hit it when it's moving away from it. It can hit it when it's moving this way. It can hit it when it's moving this way. And any of those motions will change how this photon moves the electron. And when the photon moves the electron, because it is in a pressure tension, it'll move back. And when it moves back, it'll release the new photon in a new direction. And such. So I'll give you a couple more minutes, and maybe we'll just have an early night. Yeah, it went on a little insanely late last night, so best not to do 3 hours worth. But there was people chatting, so there was questions and answers to provide, so it was fruitful. But clearly, Thursday nights are not very good, frankly. Well, I guess this is Wednesday night. Yeah, technically. All right. So I shouldn't rag on Thursdays. See how many dopes are in here. 15, yeah, that's pretty good. I think it says 15. To get my magnifier out. 15. Not altogether terrible. You should be enough to have some sort of chat. But so far, not so much. There we go. Technically, it's Wednesday night. Thank you, shithead. I figured that out on my own. Yeah, but good enough. I mean, you see, people are really good at pointing out the stuff that doesn't matter, and you're really bad at conversing about physics. So even though the room says talk physics, you can't seem to talk physics. But you can talk shit, and you can talk crap, and you can talk irrelevancy, and you can talk garbage and nonsense. But yeah, you really can't talk physics much. So let's see, what else can I say about interference? All right, there's no waves, no interference, no collapsing of a wave function. Photons don't have any of these properties. They're really simple. Have you figured out why the solar system is flat yet? Well, I mean, it really hasn't been something I find all that interesting a subject. I've just made the point that its flatness, in my opinion, is an indication that the solar system isn't created by stuff coming from the outside into the solar system, that the solar system is created from the inside. Okay, so maybe it was a binary system. Maybe Jupiter was a sun at one time, and now it's a dead sun. So at one time it was a binary system, and then when the one sun ran out of gas, it became a different kind of system. But there has to be something that's forcing the flatness. So in my opinion, it had to be binary at one time. There had to be two objects of significant mass rotating around each other for there to be any hope of creating a flat solar system. Well, I mean, the scary "I love you" thing is not terribly useful either. It's really not talking physics. Some other kind of talk. I'm kind of likable, maybe. I don't know if I'm really lovable. Cats are lovable. Smoke that pipe, whoop, whoop. Well, that's really interesting. I guess I'll have to block you. Yeah. Is that what you want? Okay. I'll let you decide. Try for comment number 4 and we'll see how good you do. Clearly not a pipe, but whatever. I used to have a benefactor named Jared. Nice person and such. Battery should go dead soon, so I'll have to resort to the other smoker. All right, well, 1 minute warning, I guess. Is there some other video I could play? I don't think so. Yeah, unfortunately, the rational science guy, like I said, when he's talking about his stupid rope theory, those videos are really boring and they're just crazy. It's just every single atom is tied by a rope to every other atom in the universe. It's just silly. You know. And like I said, his critiques of conventional science are pretty good. Like I said, the two-slit experiment was pretty poorly done, I think. But some of his arguments are better than that. And but yeah, he goes on about philosophy a little too often, and some of those arguments are worth having about what's the nature of understanding, or the nature of the word knowledge, what's real knowledge. And I would still argue it always comes down to this definition of proof, beyond a reasonable doubt, what you would actually bet your balls on, having enough evidence and to justify conviction. That is, deciding, yes, the person's guilty, like in court, or in this case, deciding that an axiom is solid. So when we say something about the universe, like there's no God, it's because we've analyzed all the evidence, all the possible ways of thinking about the notion of a God, and found all of them fall way short of possible or probable or reasonable. And there's lots of counter theories that make so much more sense than the silly theory that something intelligent made a system that is so unintelligent in its function. Somehow an intelligence creates a game that, like creating a race car track where the cars can't go around the curve and they always crash into the wall. Like a smart thing wouldn't create a racetrack that the cars can't turn on, where they could crash into the wall every time. Smart things don't make stupid things. So, lots of arguments like that. So you can dismiss this whole God theory or intelligent designer theory. And so then you can have an axiom that says, yes, we got to start with the assumption that the universe isn't guided by intelligent notions. It's just guided by mechanical mechanisms. And what are the mechanical mechanisms capable of creating? And then you get into the subject of evolution and all that kind of stuff. The replicating of a molecule, the fact that the errors turn into advantages, and then the advantages are kept. The Xerox machine imperfectly copies, and sometimes an imperfect copy is a better copy than the original. And then you start to understand, it's a error is its function. Okay, error is how it achieves advantage, and then that definition of advantage can change. So anyway, I'm doing philosophy while I'm explaining philosophy, but the process of philosophy is just like the process of science. You have evidence, and you measure how good the evidence is, and then you establish axioms with that evidence. And I'm just arguing physics is way ahead of the evidence. They have a tiny amount of evidence for conclusions, and they jump way ahead as if they have reason to convict, reason to create axioms. And they're way short of the evidence to jump to those conclusions. And then they close their mind to any counter theory because they've established that it's black, and they will not accept any evidence demonstrating that it's white. They just say, we're not listening. We decide it's black. That's it. Reject everything that doesn't match experiment. Again, what experiment? And match experiment how? They say they have experiments where they've tested entangled particles. Do you believe those experiments are truly testing entangled particles? I've just pointed out how they have an interferometer that they think has wave interference in it somewhere. And I've just demonstrated through 3 different drawings how there's no theoretical ground for this interference to even take place, that I can't even find a mechanical place in the device where the 2 photons could interfere with each other. And there's certainly no place where a single photon could interfere with itself in any way that the rest of the device would be in use. The rest of the device would be irrelevant. So it clearly can't be part of the function. So I've just demonstrated that the experiment has idiotic axioms, a nonsensical theory behind it, and the conclusions you can draw from it can't be what they've drawn because the device can't do what they think it's doing. So what does it mean when you say reject everything that doesn't match experiment? I mean, it's really not a useful statement, in my opinion, unless you have an experiment that's so obvious. The statements made about the experiment's results are undeniable. Well, these statements are deniable. So it has to be put in the category of an experiment that is dubious or unproven or something like that. So would you say reject everything that doesn't match unproven experiments? I mean, I think we should consider everything that doesn't match unproven experiments. Maybe I meant match reality. Experiments can be wrong. Well, again, just saying match reality. Again, how do we ascertain what reality is? So this is the problem I'm trying to describe. Is the whole point is much of the evidence we have for reality is weak evidence. So my point is there has to be caution in jumping to conclusions. And especially in physics, they have no reason to jump so far ahead of the evidence. There's no reason to think wave is better than particle. So there's no reason to pervert perspective to make waves the reality when there's no rationale that says the wave theory is more powerful. Well, it's not really more powerful. The particle theory could be just as powerful. So, there's no reason for this bias, but the bias is obvious. And it has to do with celebrity of Einstein. It has to do with a lot of things that happened in the evolution of this concept of physics, and a huge change from Newtonian physics in the sense that Newton had to have evidence to draw conclusions, and current physicists don't need any evidence at all to draw conclusions. They can start talking about things for which there's absolutely no evidence, and they'll just speculate about a magical dark matter, a thing that is just as God of the gaps as it can get. It's just a completely made up thing that solves a mathematical problem. I mean, it's contrived evidence. There isn't even any, there's no physical reason, there's no compelling reason to believe it, except it supports their fairy godmother theory. Look at yesterday's comments. I don't know what that means. I don't think the comments on my videos were of much use, but yes, I suppose I should do the comments. I usually do that, don't I? I'm just so down on the comments. Have just been so useless. I mean, people are just so stupid. I mean, see, this is an example. This guy was writing. He wrote like 17 comments talking complete gibberish, and I left the one up there. As I said, okay, I'll even have his one comment. So in all capitals, he's writing this crap. Okay, nerd, he can't hear me. This is the question. Is time moving creature? I mean, I should waste time reading this slop? like current, like energy that can be sped up and slowed down? Or is it a arbitrary measure like a ruler? Or is it both? I've already explained time 4,000 times on this channel. It's just such a waste of time to have to explain that time just has to do with the fact that it takes time for things to happen. They don't happen instantaneously. So things can't move through space instantaneously at instantaneous speed. So therefore, there's time. That's all it is. It's a byproduct of the function of moving objects. Nothing more. That's my question. Who cares? IDC, if you use science or questioning it, it's good question. I don't know. Anyway, so this Jeremy guy tried to respond to his retardedness, but I don't know why he bothered. He's a retard. Time is simply a measure of a sequence of events. It's a measure of the fact that the events do not happen instantaneously. Time could stretch or grow in this way. Yes, you could double the speed of light and the universe changes. Now, I would argue it would probably change in some critical way that means the universe would have to change in other ways too, because that speed would break certain functions. Earth spins around the sun. Doesn't really spin. At its current position, it takes a certain amount of time or distance for the Earth to circle the sun. And again, it doesn't really circle the sun, but okay. But if you move the Earth farther away from the sun, it would be more distance. Since Earth is farther away, well, I'd also have to move slower. But anyway, that's a whole nother point. The Earth to circle the sun. It would take a longer amount of time for Earth to circle sun because Earth would be further away. Again, it's not just about being further away. It's how much weaker the force gets. So it's the inverse square law problem. So there's not a proportional relationship between distance and velocity. Your velocity has to get much slower than your distance. So as you increase the distance, you have to quadruple the reduction in speed. Let's see. Yeah, so I already read that. So I don't know why this guy want me to bother with these idiotic comments. Maybe he meant the chat in the last video. I don't know. I don't know what that statement meant. Well, you really didn't miss anything, did you? I mean, this wasn't worth me reading. Ah, there's a new one by him, I guess. Ash says you can't tell, but we burning out. Ash says you can't tell, but we burning out. Wow. What the fuck is that? So he wrote a bunch of other crap. And then this Joseph guy jumped in. We have a serious problem because we die sooner than turtles or trees. Retard. As much as we are the stars, we really aren't that spectacular. I mean, whatever. You know, we obviously have functions that are more spectacular than a frickin' pine tree. My daddy watched the Titanic sink before he knew what he was exposed to. I don't even know what that means. Time and space is real. Just baby talk. Foolish hope to see something worse than the tides getting angry. Poetic mush or Mother Earth smacking you. More mush. Look at what you have to see. Time can be a bitch. Useless crap. So I missed something here? No, I didn't miss anything here. Ash says you can't tell. I don't know what that means. But we burning out. I'm just deleting it because it's mush. I'll leave the other retarded thread, but it's all retarded. I mean, you people are all fucking idiots. Sorry. So, 1 minute warning again. I should have left. Disappointing. Anyway. Hot. All right, 30-second warning. Might be a 10-second warning. Ooh, it was all sticky. Mr. Keebler, nice to see you. Well, tonight was informative. Thanks, Gary. Well, thank you for that. At least you sort of got it that I did explain some things that nobody could seem to talk about, but at least I did explain them as best I could. Explain why you people shouldn't be so convinced that these talking heads know what they're talking about when they say wave interference. It doesn't really, it's not what the evidence points to. So, okay, well, I guess that'll be it then. So, till it'll be the next time and such, and so forth and whatnot. Such. Let me see how many were here. 15, 16, 18? I really can't see too good. 18. Yeah, 18 is a lot for no participation. No, that is a little disappointing. 18 viewers should be able to type something. Oh, here we go. That's the old stuff. Yeah, okay. Yeah, it almost fooled me. All right, anyway, till next time. Such.